So I'm going to give more of an organic cover crop perspective from the upper Midwest. And before I get started, I just want to put a plug in for O-Grain. And O-Grain is a comprehensive organic grain extension program that was started in Wisconsin, largely by Anders Gerda, which is sitting here in the front. So if you want to know more information about what I'm talking about today, you can Google O-Grain Wisconsin. We have a listserv too if you want to get on that, where we talk about cover crop issues in organic as well as advertise our various events. So unique aspects of cover cropping organic systems generally. I'll give a bit of broad overview and then a few examples of how cover crops are being used in organic grain systems in the upper Midwest. In organic systems, cover crops are required as part of the organic regulation. It varies how an inspector or certifier interprets that part of the regulation, but certainly organic farmers have used cover crops for decades. So they've been pretty creative about them already, and they're pretty routinely used in various ways in organic grain systems. They're an essential component of fertility and weed management plans. Certainly, again, that varies depending on farmer resources and strategies and what their exact rotation is. But without the use of cover crops, organic farmers are certainly at a huge disadvantage with respect to getting nitrogen in their system and managing weeds effectively. But some management considerations are certainly different than conventional systems. I would argue that there's no efficacious or economic herbicides available on the organic market that are allowed in certified organic systems. So termination must always be achieved by either winter kill, by senescence, or by mechanical means, which adds an element of risk and an element of uncertainty. Without the use of a herbicide, certainly we must work within our environmental constraints, as well as be a bit strategic on how we're going to manage this with the different cash crops. Without insecticide seed treatments, insect interactions must be weighed and managed differently. Especially in the upper Midwest, depending on when flights of insects are coming in from the south, we have to strategize termination. For instance, many of the cover crops will release volatile compounds that will attract the adult moths that will come in and lay eggs. And depending on when those flights are and how long after those insects may be laying the eggs, they can certainly cause a lot of damage to the emerging cash crop. For instance, with like a rye or any sort of green manure cover crop, you need to incorporate that 2 weeks before planting a corn crop to make sure that seed corn maggot is in time so that it comes in, lays the eggs, and then emerges at the time that your corn crop is going to be emerging. Similarly with armyworm can really be a huge issue, as I found out this year. And it's one of the reasons why we can't do, as Chris was saying, organic no-till corn into various cover crops, especially grass, cereal grain cover crops, because those armyworms, depending on when their flights are coming in from the south, will lay eggs on the cover crops, emerge, and then decimate the cash crops that are planted within those cover crops. So without really any seed treatments and even limited insecticide options as well, it definitely is a risk. And there's also, again, more severe consequences of unintended interactions, including exacerbation of weeds or contamination from volunteer crops. I've heard some horror stories from farmers, especially in the organic no-till system, of volunteer crops coming through, setting seed, and then contaminating the following cereal grain crop that's being sold as a food grade crop, and not realizing that interaction is going to occur. So a lot of thought, a lot of strategy, and a lot of determination and weighing of risk needs to happen in organic, because if these things do get away from you, there's less cleanup methods, I guess, to say, in terms of solving those problems that arise. Some other unique, go ahead.
What you were talking about on insects and grass cover crops, is that less of a problem if we're using a legume cover crop plant into?
I think they tend to be. Some of these, like armyworm, for example, tends to be attracted to cereal grain cover crops, grasses. So some of these are specifically attracted to grasses. So legumes, I believe that there's less interactions. I'm not an entomologist. But for instance, this year the pressure was just so high. Usually in the rye soybean system, I've never seen them attack soybean, but this year the pressure was just so high that there's just such a population out there that they're going to eat whatever they come to. So it's a risk. It's something that we need to scout for, something that we need to have in our minds, that we need to be looking out for and have proactive solutions of what's going to happen if that is to occur. But yeah, legumes tend to, I think, have less of that interaction with insects. So some unique challenges, specifically the upper Midwest. We have a very short growing season, relatively speaking, as compared to the other two speakers that you've heard. It can be very difficult to fit cover crops in, especially after corn and soybean harvest. Traditionally, we've been reliant on cereal rye. Cereal rye has excellent winter hardiness. We can plant it very, very late. It germinates at soil temperatures around 33 degrees Fahrenheit. But that still is pretty limited with respect to the diversity we're adding to the system and the ecosystem services that crop is able to provide. But it's something that we need to manage around. And we are seeing, especially this winter, we've been seeing it, temperatures that are increasing. Our lows are not as low as they used to be. Ironically, that actually can be a bigger issue for overwintering cover crops than the temperatures we had been getting in the upper Midwest, because that snow cover serves as a great insulator. And the fact that we're getting dips in really cold temperatures and then warming back up again and having these freeze-thaw events without that buffer, that snow cover, some of the crops that have been overwintering will actually get more winter kills. So honestly, with the changing weather patterns, we may be more at a risk with overwintering versus less at a risk. We tend to have wet springs, not always, but certainly, again, strategizing and thinking of worst case scenarios. If it is wet in the spring and we aren't able to get out in the field, there's a risk of that timely incorporation of the cover crops, which again can exacerbate insect issues, could potentially lead to fertility issues, other issues with allelopathy and emergence of the cash crop. So always thinking of the plan B and looking at the weather and thinking of how you're going to do alternative management. There's also very few legume species that will overwinter in Wisconsin, in the upper Midwest. Certainly hairy vetch has been a mainstay, and there's some clovers that can be used, but compared to even Illinois and just south of us, we're pretty limited in the upper part of the US. So talking about some successes and innovations. Interseeding, we're seeing more interseeding happening into standing corn. This is not too much different than what we've been seeing in the conventional side of things. Here, we're still doing cultivation, and we can typically time our last cultivation so that by the time the corn reaches the B5, B6 stage, we're getting some decent canopy coverage. And in that time, we're still getting some light, though, that's reaching down within the corn rows. And there we can use modified drills, interseed a cover crop, and get some sort of diversity and cover within that field. We've tried red clover to be able to let that red clover come through, especially for harvesting that corn for silage, so that we're removing most of the biomass off the field. But certainly we've been seeing that be successful in the upper Midwest as an option of diversifying the system of cover crops. Here there's red clover on the left and then cereal rye on the right. We've been curious if the cereal rye planted into corn, we can get good enough biomass to do a no-till soybean crop after that. Chris talked a lot about this, but we've also had really good success with the cover crop-based rotational no-till in soybeans. Chris explained the system. We've been seeing exactly what he's been seeing. The first 2 months, you walk out there in the soybean field, and it's a little bit frightening how lagging those soybeans are. It takes till the end of July, early August for that nodulation and nitrogen fixation to kick in, and then those soybeans will pop up. And that's a soybean field in late July, and like Chris said, those are looking a little peaked, but those will take off. But it's a weed-free field. It really is beautiful. It can work really, really well.
Is the termination of the rye in that, is that done with the same crimper type implement that Chris was talking about?
Yep, we use the one that Jeff designed, the Rodale model. This one's rear mounted. We do typically use it front mounted now, but it kind of depends on our strategy. We've been doing some experiments doing an early planting, going into standing rye at the boot stage and then crimping over it, which had worked well. This year did not work well, which is always, the environmental risk of cover crops, and it's not necessarily a sure thing. This year we had such a cold, wet spring that it was just so even colder and wetter in that rye cover crop that we just had issues with germination and stand establishment this year. Even our control plots, though, were our later planted soybeans yielded about 10 bushel an acre, even in the traditional organic system. So it really was more of a function, I think, of the weather this year. But we've had some good luck with the early planted system and then crimping over the emerged beans at about the V1, V2 stage. But yeah, that works well. Similar to Chris though, corn is just so far a no-go, but for different reasons than what Chris said. For us, we just don't have a legume that's going to overwinter and put on that biomass. Vetch for us, we have to get planted in August, which really limits our windows of where we're putting that in. We can put it in after a cereal grain crop. We need to get it in really early, but it doesn't flower for mechanical termination until really late. So we're talking not being able to plant corn until like June 20th, and that's just too late for us even for a silage crop. So we're really looking at some other potential options, including crimson clover, like Chris mentioned. I've tried some spring planted legumes, but those just, the biomass just breaks down much too quickly. The seed-N ratio just isn't right in trying to plant into that. We just don't have the weed suppression for as long as we need. So, like Chris, I'm not going to give up. I'm still pushing ahead with the no-till corn, but so far it's been a struggle. But no-till soybeans, the station, the research station actually does them routinely. It's just part of their organic soybean production because it works so well. It's a beautiful system. Here's a picture again in like middle to late July, no weeds. Here you see a little bit of breakthrough weeds. Unfortunately, it's a bad one for soybean. We have some nightshade in there, but I mean, otherwise it's a pretty clean field. That field just happened to have a little bit higher nightshade pressure there, but that's the end of August. Yields in this system have been really, really good. There's a learning curve for me anyway. So the first couple years I had a bit more of a yield lag, but in the last few years, yields have been statistically equivalent or not even a little bit higher. So the system can yield quite well, but you really need to do it well, which means planting the rye early, planting a high enough rate of seed on the rye, and really managing for that biomass. I actually try to get a little bit higher than 8,000 pounds per acre, more like the 10,000 pound range, but that really trying to shoot for the weed suppression. Benefits, there's definitely been market benefits that have been documented, including higher microbial activity, potentially mineralized with nitrogen, increases in soil bulk density, increased water absorption, so it really is a system that can provide multiple ecosystem services. Works with specialty crops as well. I'm going to fly through this a bit more, but it's been a little bit more challenging. It's because of the fact that we're talking, like Chris said, nitrogen tie-up in the system, so having to manage the nitrogen can be even more challenging. This is a squash plot we did. It really was beautiful. We tried to have wider rows though, so we could manage the nitrogen better, so there was less competition between the vegetable crop and the cover crop. And here we did find from some of the preliminary data that the mulch plots yielded better because there was more moisture retention during the middle to later part of the season when the fruit was setting, when those crops were a bit more stressed for water. I just want to talk lastly about a few novel intercropping techniques that I've been seeing. Well, the one on the far left, that's planting red clover into a standing winter wheat crop, and that's cross-seeded in the spring. That's something that's routinely done in both conventional and organic systems, and is a way to get a legume crop in there early. And if you're following this with corn, it can be a great way to get nitrogen in the system and establish that legume crop early. So that essentially, that's broadcast seeded, the red clover over the winter wheat crop at the end of March, and then that starts to germinate and establish and is there ready when that wheat is combined. This is another technique that I saw, we actually saw at one of our O-grain field days in Illinois. I hadn't seen this before, but I tried this, not with great success, but some of the farmers I work with tried this. They're actually planting a cereal rye, winter annual rye in the spring. And depending on whether they're a little bit further north or a little bit further south, they're either drilling the soybeans at the same time as rye planting, or planting the soybeans a little bit later after the rye emerged. But because that rye doesn't get a chance to vernalize, essentially what it does is it comes up, it's about 6 inches tall, and then basically dies back down as a mulch. And you can see on the far right there, there's some mulch there under the soybeans. That's just from the rye coming up, staying at the vegetative stage, and then dying back down in July. And that's a field that I took out in a farmer field in Wisconsin, and that's soybeans with using that technique. It's a pretty clean field. We see some foxtail there, but it's not too bad. And this is another field that we took from another O-grain field day farm up in the central part of Wisconsin this year. They did the same thing, which kind of scared me because I mentioned this last winter and I was like, I'm not sure if this is going to work because I haven't seen it that much and I haven't tried it. They went out and did it and worked beautifully. So again, this is cereal rye, was planted in the spring, planted soybeans at the same time. I tried to pull those soybeans away so you could see the mulch down below, but it really came out to be a pretty good field. That soybean, even that just spring vegetative rye, makes a nice mulch and keeps the weeds down. So there's no tillage in this system. No cultivation. We do, well, that's, in these no-till systems, we do recommend using a higher rate, in part because of the issues with emergence, in part just to get the canopy cover. So the economics in organics still pan out, even with that higher seeding rate, because of the labor cost and the fuel savings. So we're typically recommending, I usually plant about 225,000 seeds per acre. I've seen recommendations go up to 300,000.
Is that even on 30-inch rows?
The rye rate. Yes, rye rate. I recommend typically about 3 bushel an acre in Wisconsin, but I know other states may vary. And even in this system too. This system, I probably wouldn't go quite as high. I tried it last year in the experiment station. It didn't work well for me. I had a huge problem with Pennsylvania Smart Weed last year. So again, I put caveats on this because I haven't had this research data. I've seen this on farms that work really nicely, so I'm very intrigued to try it more on my farm. But I try about 2 bushel an acre here. Yeah, like that.
What about row
Row spacing on the soybeans. For this spring planted technique, I think I prefer to see it drilled on 7.5-inch rows. Typically on organic no-till fields, I still like to see it on 30-inch rows. I've never had to do the high residue cultivation on our fields, but I still think, at least with our planting equipment, the 30-inch rows allows for better seed to soil contact and more precision placement of the seed. And we're able to adapt that planter better, that we're able to get more pressure on the individual row units. And with the biomass the way it is, I don't feel like I need that canopy closure any quicker on the soybeans, because that rye is doing the job it needs to do up until August when I start to see that canopy closure. So I'm still convinced 30-inch rows are the best to go on the roll rye system.
So you're still recommending 200 to 225,000 seeds in 30-inch rows?
I still do. My colleagues here make different. Jeff, what do you think?
That's what I mean.
Yeah, so Jeff is saying he does 220. You still do 30-inch rows too. Yeah, so yeah, I do about 225 on 30-inch rows. But again, I've seen other data from other research units that do organic no-till that recommend it go higher. You know, it's somewhat, it goes down to your system. And I think as we look at how to improve the system overall, I think we can do so much more just in general with management of cover crops, just in general with organic, with modifying equipment. It all goes down to getting through that rye. And if you can modify your equipment that you can get through that rye and get the seed to soil contact, that soybean will come up. So if your equipment is not able to get through that rye, you may have to bump the seeding rate up. But I think if you're able to get that planting equipment good, to me, that 225 is a good way to go. And just to get a little bit, I always go over time because I swear I get on too many soapboxes now, but I just want to say that there's, one of my pet peeves is when people say, which wasn't said this morning, but I hear people say that organic is like my grandfather's way of farming, and that is not the case. Organic is as much, and organic farmers I work with, they want science, they want data, they want to understand the system, they want research, and want technology in terms of equipment and technology in the forms of models. And I think both in terms of this system, like Chris was saying, to look at models that will help us estimate biomass and estimate how our cover crops are working in our systems. In the terms of nitrogen contribution as well, hugely needed for organic and hugely welcomed by organic farmers, as well as equipment modifications and technology. And anyway, off that soapbox. But organic is as much, to me, data and science-based as any other form of agriculture. So I'll end with this slide, where's more research needed? I think we need more breeding of cover crops, particularly with overwintering and optimizing other ecosystem services. The agronomics, estimating the predicting, again with models and other sort of science-driven technology, intended and unintended consequences, as well as equipment optimization, and then overall quantifying ecosystem services.